Hello and welcome back. My name is Karthik and we are coding supervised learning. For those who are joining us right now, this is a second video of our first video in which we coded and did some importing of libraries and exploratory data analysis. Today we will do exploratory data analysis and we will play with some graphics and graphs and yeah, we will do that today. And if you're new to the channel, just subscribe, like and comment, and if you're old, just like and comment and tell me what I can do, what I can do better. If there is some errors, you can tell me, because again, it's all about learning and growing together. So let's start. Okay, so as I said, we will work with some graphs and all. So to work with a graph, there is a library which is known as Matplotlib library, and that is actually used for plotting a graph in our for our data sets. So let's first install that library. You can pip install that Matplotlib library, and if you have installed Matplotlib library, you don't need to install it again. But for safety's sake, I will show you here. So it is like pip Matplotlib, yeah, pip install Matplotlib. So this will try to install Matplotlib, which is Matplotlib library in our Jupyter notebook, which we will use to which we will use to draw some graphs and all. And as you can see, this here says requirement already satisfied, which means I have Matplotlib library installed in my system. So now we have to import Matplotlib library. So we'll say import matplotlib.pyplot as plt. So this will import matplotlib.pyplot library, and whenever we will use plt, that means that we are using matplotlib.pyplot library. Okay, so let it import first. So we have this much done. We have done this much, like importing library, importing our data set, and everything. If you need is in the description. If you want to read all about supervised learning, the link is in the description provided. I have written a blog where I have explained everything and every algorithm for supervised learning. Well, that said, now we will run every cell, because why not, just to be on safe side. So yeah, just run all the cells. Okay, and yeah, we are good to go. So we have done explored our item fat content, I guess, in previous video. Yeah, we explored our item fat content. Now what we can do is we can explore item visibility. So what is item visibility? So item visibility is basically the percentage of the product of same product present in a store. Let's say there are 10 Lay's packets, 2 Cheetos packets out of 100 packets. So if we take their percentage, then like Lay's is 10% and Cheetos is 2%. So that this item visibility is basically that, like how much percentage of that product is present in that store. Okay, so let's explore that. I'm just stuttering for no reason, I guess. Okay, so we will say train is our data set where we have stored our data set. So variable item visip QI, and let's see in graph form, because we have like imported our Matplotlib library, so we will plot a histogram, or like histogram is basically a graph where there is a hierarchical pattern, and it will show us some bar chart and something. Hist, we will say their bins is basically the size of one box, so we are saying bins 20, so it will give us the 20 size 20 bins of histogram. So as you can see, so there's this is showing us the item visibility, this thing, like item visibility thing, where is that? Yeah, item visibility thing on the graph. This is not the value which we are getting, these are the value which we are getting, like 0.016, 0.019, 0.016. so this is actually plotting that thing. Okay, now let's say we have to find quantile. So what are quantiles? Let's explore that. What are quantiles? Okay, so first of all, let me show you something. Let me get a good an easy way to graph to make you understand. Let's take this graph. Okay. So yeah, this curve is known as bell curve. This curve is known as bell curve, which is a normal distribution curve. Normal distribution is a statistical term which actually is a very fancy way of saying that how our data is spread, and how normally our data is spread. And yes, it has a formula in statistics, and it sounds very complicated, but when you dive into statistics, that thing becomes easy. It is something like 1 divided by root 2 pi standard deviation e to the power x minus mu 2 standard deviation square, something like this. So that is a formula of normal deviation. Okay, so that formula gives us this bell curve, and this part, the 25%, this is known as our 25th percentile. So this is known as first quartile. Okay, this is our 25%, this is our 25%, this is our 25%. This area from here to here is actually median, which is known as inner quartile range, which is like Q3 minus Q1, which is quartile third minus quartile 1. And if you see closely, this 25 plus this 25 is 50, plus this 25 is 75. So this area is 75th one. So our third quartile is basically 75th percentile of that normal distribution, and our first quartile is 25th% of that normal distribution. So to find inner quartile, we just subtract Q3 minus Q1. There is one more formula which we will use to calculate our interquartile range, which is Q1 minus 1.5 into our inner quartile range, which is Q3 minus Q1. And to find out 75th one, we will say Q3 minus 1.5 into our inner quartile range, and that will give us the value of our IQR. That will actually give us the range of our IQR, the percentage. So if you understood the in quartile and inner quartile range, let's explore it. So let's do this for Q1 is equals to train, and we will take item and visibility dot quantile, and we want our first quantile. So as I told you, it is our 25%, which is like 0.25%. so this will give us our quantile. And how we are able to use this quantile thing, because we have actually imported the library math and sqrt. We imported some matrix library, and these are the libraries which help us to do maths. We have used numpy, which is also helpful for doing maths. So we said that q1 is our this, then we will go and find q3, which is 0.75%, and we will go and say q3 and train item visibility and it should give us the q3. And as we seen, our IQR is equals to q3 minus q1. Let's execute this, and if I say IQR, it will give us the interquartile range value, which is 0.0675, which is actually this value between this and this. So now what we have to do is we have to make a training set or train data. So let's make a variable which is like filled train, which is filled to train, and the formula which I told you was, first we will say train dot query, if I'm not wrong, query by train dot query, and the formula for that was @q1 minus our 1.5 multiply IQR. This will filter the value, and it should be less than equal to train visibility, item visibility. Okay, item underscore AITY. This will less than equal to @q3 minus 1.5 multiplied by IQR. Okay, this is the formula which should give us our train query filled underscore train. If I think this will show error, if I'm not wrong. Yes, this will show error, because if I have not passed the value of IQR, which is this, and the error must be, let's check after doing this, the error must have been that there is no IQR, because I was not passing this IQR value to this. And after doing this, hopefully it will work. Okay, it got executed. So if we want to see our filled filled train, so this is actually and this is actually giving us a column name, because we are going to do some operations here. So let's say okay, let's use some command to see, like we can see here shape, and this will give us we don't have any rows, so 0, and we have I think 15 or 16 columns, so 0 comma 16, has a shape filled train shape 13. We had 13. Like if we want to count, let's count. So 0 1 2 3 4 5 6 7 8 9 10 11 12, and that value which I took 0 was actually started from 1, so 1 to 30. So and if you want to see the train dot shape or original data, this is here. See, 13 columns, and we actually got rid of every rows because we have to perform some operations there. So let's go ahead and say train. Okay, train item with CPI underscore bin. Let's say bins, item visibility bins is equals to. So what we will do, we will get some data from our original, and we will try to make a data new column of this. So PD, we are using pandas.cut. We will use cut to cut the data, like it performs an operation of cut. We will say train, which is our original data. We will take the original column from our original data frame, which is item with a bi with a pi. Then we will perform some operations. Let's say, okay, let's say we give some values. I think it will be 3. Yeah, this is actually the range which I am giving: 0.006, 0.15, 1.3, and let's go ahead and say 0.2. We should make 6, 5, but it would be greater than this. No, I think this is good. And say labels is equals to lowest, which is low visibility. Like if something less than that will be low vis. It has visibility, and high vis, like high, it has high visibility. Let's execute it. Okay, it got executed. And what we can say, let's say, like if there is any value, because we as like we made a new column, we took our data frame and we took the column from that data frame, and we have said that these are the values or a parameter on which we are setting our visibilities, and these are the labels for which are associated with these values. If 0.06%, then low vis. If 0.013, 0.000 and 0.006 will fall under low vis. 0.006 and 0.13, some products between them will be visible, like it has a visibility. 0.13 to 0.2 is actually high vis, so we are seeing that. So now let's say how many such items are there. Item VILI and bins, and we will use value underscore counts. Let's check. Okay, there is some error, which is what? Trainer item visibility item VI. Okay, LI there. So there are 42 products which fall under low vis, 903 products which falls under high vis, and 6918 products which are actually which have visibility. Okay, now what we can do is, if there is some null value in visibility, which there are, if I'm not wrong, yeah, they have 0, 0, 0 and something, so we want to get rid of that, and let's check some for low vis. Let's do something for low vis. Okay, so we have said that item visibility. Okay, so let's go and say like train item bins, item visibility bins is equals to, so we are doing something for like null values. So let's say train, okay, it is under train item, we'll say bins dot replace, because we are replacing some values. So what kind of values we are replacing? We are replacing nan values, so we will use np dot nan for that. And we are saying if like they are low vis, which there is certainly a case, then we will say reg, which is actually a function inside our Python. Reg is true, and let's execute it. Let's see. So let's if it's like if we wanted to see, let's say train before this, train item is a bins. So see, before that there was this nan values present there, this nan value present there on third, fourth, and vis and high vis. Okay,